Hey guys, today we're going to look at we're going to start our unit on Unit 8, which is quadrilaterals. And our first lesson is going to be finding angle measures in polygons. So let's just recap some basic things. Just remember, the term polygon means many angles, so it means you have more than one angle. For a figure to be classified as a polygon, it must be a closed figure formed by segments in a plane so that the sides that have common endpoints are not collinear, because they're not on the same line. Each side intersects exactly two other sides at their endpoints only. A convex polygon. So if you extend any segment to make a line, no point on the line is on the interior of the polygon. Whereas a concave polygon is a polygon that is not convex, obviously. A convex polygon is called a regular polygon if all the sides, it's a regular polygon if all the sides are the same length and all the angles are congruent. So if we go ahead and look at this triangle that we have right here. If we extend any segment to make a line, so I'm going to extend this segment right here to make a line, is any point on the line on the interior of that polygon. So any point on the line is not on the interior, which means the inside of the polygon. So this is convex. If I go ahead and extend the line here, is any point on this line on the interior, on the inside of the polygon? And unfortunately, this occurs. This point right here is on the inside of the polygon. So if it's not convex, it's concave. Look at the figure we have next. So if I extend any segment here and make a line, no point on the line is on the interior. And that holds true. So this would be a convex. Now, in order to decide if these convex polygons are a regular polygon, all the sides have to be the same length and all the angles have to be congruent. Well, is that going to happen in a triangle? It is not. What about this figure over here? Do I have all my side lengths the same? If all my side lengths are the same here, which they are, then all the angles are going to be congruent. So this is a regular convex polygon. All right, let's move along to the next. So the diagonal of a polygon is a segment that joins two non-consecutive vertices. So if I look at this polygon to the right here, let's see how many diagonals I can get. So here's one diagonal. And that joins those two non-consecutive vertices. They're not right next to each other, those vertices. I can do one here. I can do one here. Where else do I have some diagonals? Did I miss this part? I missed that one there. Oh, and I also missed this one right here. So that shows all my diagonals inside of there. All right, in each of the convex polygons below, pick one vertex and draw all the possible diagonals only from that one vertex. Do this for each polygon and fill in the table with the number of sides and the number of triangles formed. So if the sum of the angles in one triangle is 180, what is the sum of the interior angles in each polygon? So if I have number of sides, if it has 3 sides, clearly it's a triangle. So there's one triangle that makes. So the sum of your interior angles is 180. What about if I have a figure that has 4 sides? Well, let's go ahead and look over here. How many triangles can I end up making? If I do my diagonal there, I can make 2 triangles. If I have 2 triangles, the sum of the interior angles are 360 degrees. In a 5-sided figure, how many triangles can I end up making? Well, I can make one right here. And so I made one right here, and one right here. So I end up making 3 triangles And 3 times 180 is 540. So do you notice the pattern as to what is happening here? In this 6-sided figure, how many can I make there? Well, if I draw a diagonal from the same vertex, it looks to me like I'd get one there. To go from the same vertex, remember, I'd get one there, and it looks like I could get one right there. So I have 1, 2, 3, 4. And 4 times 180 means the sum of the interior on a 6-sided figure is going to be 720 degrees. So we probably can go ahead and fill up the rest of this, because do you notice the pattern as to what's happening? 1, 2, 3, 4. This one would be 5. 5 times 180 would be 900. The next one after 5 would be 6. So an 8-sided figure has 6 triangles that can become inside, and 6 times 180 is 1,080 degrees. So how am I getting this? What is that formula there? Well, the formula is I would do n minus 2, because notice, if I'm at 3, I take 2 away from it to get 1, and then I multiply that by 180 to get my 180. If I'm at 4, I take 1 away from that, 2 away from that to get my 2, and then I multiply that by 180. If I'm at a 5-sided figure, I take 2 away from that to get 3, and multiply 3 by 180 to get 540. So I do my n minus 2, and then the last part is n minus 2 times 180 degrees. So that is the sum of the interior angles formula right here. We'll need that for later on. All right, let's go on to the next thing. So this right here is basically what we just found out using the pictures that we saw in that last table there. So if S is the sum of the measures of the interior angles of a convex nonagon, you don't know how many sides it has, then what is the formula going to be? So the formula for sum of interior angles is just what we had before. N minus 2 times 180 degrees. And N is going to be my number of sides of that figure. All right, let's go ahead and practice some problems on this. Find the sum of the interior angles of a regular convex 18 gon. 18. Where am I getting 18 from? 82 gon. So let's ask ourselves, how many sides does this have? That is my n. This has 82 sides. Remember the formula. I take 2 away from this. If I take 2 away from that, 82 minus 2 gives me 80. And then I go ahead and multiply that by 180 degrees. So I totally don't expect you to do that in your head. Go ahead and multiply that in your calculator. 80 times 180 degrees, what is that going to give me for the sum of the interior angles? And that is going to give me 14,400 degrees. So the sum of the interior angles of an 18 gon figure, I keep saying 18, of an 82 gon figure is 14,400 degrees. The next question seems to be a little bit different. So let's read this question. The sum of the measures of the interior angles of a convex polygon is 2,520. Classify the polygon by the number of sides. So this time they're giving me the degree measure. I need to find n. I need to find the number of sides. So use your formula. N minus 2 times 180 equals the sum of your interior angles. Well, what do I know here? I know the sum of the interior angles is this. Replace that in your formula. How am I going to solve for n here? So think about that as a little bit of your probably pre-algebra skills. You all know how to solve this by now. So what am I going to do here to go ahead and solve? I want to solve for n, so I can't touch that until I get rid of everything else. Get rid of that 180. When it's next to each other like this, what is it? It's multiplication. The opposite of multiplication is division. So go ahead and divide both sides by 180. When I do that, I'm left with n minus 2 on the left. I don't need the parentheses now because there's nothing next to it. So I'm left with n minus 2 on the left And what is that divided by? Well, that cancels, so 252 divided by 18 looks to me like it's 14, I think. And then finish solving. If I want to get n by itself, get rid of minus 2, so add 2, so n equals 16. So, a 16-sided figure had interior angles that measured 2,520 degrees. So I just had to work backwards there. All right, let's look and see how we can find out the exterior angle measure. Exterior means angles on the outside, are formed by extending the side of a polygon in one direction. Each of the angles formed on the exterior of the pentagon below are exterior angles. So right here is an exterior angle. Right here, I extended the line there. Right here, right here, right here. Those are all exterior angles. First of all, let's find what is the sum of the interior angles. Remember the formula for sum of the interior. N minus 2 times 180 degrees. Where n is my number of sides. How many sides does this figure have? It has 5. So 5 minus 2 times 180 degrees. So what's that going to give me? 3 times 180? Is that calculator? And I'm going to get how many degrees? 540 degrees? So all my angles inside of the triangle are going to add up to 540 degrees. What do you know about the interior angles? What are some thoughts? Any thoughts here of what I know about those interior angles? Hopefully you know that they are going to be congruent. Because, and how do I know that they're going to be congruent? Where did I get that from? You see this last part here is how it says, assume this is a regular polygon. If it's a regular polygon, then what is going to occur when it is a regular polygon? All the sides are the same length and all the angles are congruent. So that helps me answer this question right here. So then, therefore, what's the measure of each interior angle? If I know that all the interior angles should be 540, divide that by how many angles I see on the inside. I got 5 on the inside. So if I do that mathematically, I get 108 degrees for each interior angle. How is that now going to help me find the measure of each exterior angle? Well, let's think about this. Let me do some erasing here. So, if this angle is 108 degrees, what is this angle right here going to be? What's that one going to be? What do these angles form? They form a linear pair. So what do they have to add up to? Very good, 180. So 180 minus 108 is going to give you what for this exterior angle? So that exterior angle ends up being 72 degrees. Y'all, the same thing's going to happen for every other one because we already said that all these angles, interior angles, are 108 degrees. So if this one right here is 108, it makes a linear pair with this one. So it has to be 72. So all of them, all the exteriors are going to be 72. So what is the sum of the measures of the exterior? I have 1, 2, 3, 4, 5 exterior angles. If each one is 72 degrees, and I multiply that by 5, the sum of the exterior angles is going to be 360 degrees. So using what we just learned, let's find the sum of the measures of the exterior angles of the following polygons. So, if I have a square here, what do you know about a square? My board is a little messed up, so let me just fix that really quick so it doesn't cause us any issues. Let's see if that can be done. Alright, so we know that a square has all 90-degree angles. So if I want to find my exterior, extend your line here, extend your line here, extend your line here, extend your line here. What's going to occur? If I know that this is 90 degrees, how can I find this one? Well, they're a linear pair, so each one has to be 90 degrees. So each exterior is 90 degrees if there's 4 of them. 90 times 4 equals 360. Look what kind of figure I have here. I have a triangle. There's 3 sides. So if I extend every side, what's the measure of my exterior angles here going to be? So if this one's 45, what does that one have to be? They're a linear pair, so 180 minus 45 gives me 135. 75, 180 minus 75 is going to give me 105. 180 minus 60 is going to give you 120. If I take all of these exterior angles and add them up, what is their sum going to be? I'm going to get 360. So what does that help me figure out here? Exterior angle sum theorem. In a convex polygon, the sum of the measure of the exterior angles, which one at each vertex, is 360 degrees. That's going to occur in any convex polygon. Alright, let's go on. Let's try one or two, well, let's try one more practice problem. And then I'm going to see if you guys can come up with, if you guys can finish the rest of the practice problems on your own. So the directions here say the measure of an exterior angle of a regular polygon is given. Find the number of sides. So if I'm given the measure of an exterior angle, remember what we just figured out. If it is a regular polygon, the exterior angles are going to equal how much? And we just figured out in our previous little recap there, we just figured out that they're all going to add up to 360 degrees. So if they're each 30 degrees, and they should add up to 360, what's the number of sides going to be? How am I going to figure that out? Well, take your 360, the total that the exterior angles to measure up to, divide them by what 1 is, and see what that gives me. Those zeros line, cross off. 36 divided by 3 is 12. So this means that n, my number of sides, is 12. I have a 12-sided figure, and the exterior angle on my 12-sided figure is 30 degrees, for a total of 360 degrees for all of my exterior angles. So let me ask you this. Does anyone know what a 12-sided figure is called? And it is called a, I can't even say this correctly, a dodecagon. All right, I think you guys can handle the rest, so you are going to complete 2 through 6.